Welcome back, friends. Welcome to the next session on Terraform. As I discussed in the previous session, we already have VPC, we have a subnet, we have a root table, we have a access control list. Everything is configured. That means required networking resources are available on my AWS. Let me explain what is there in this session. This is the next session, which is Terraform configuration language syntax. The objective is to understand the blocks, arguments, attributes, and meta arguments, understand the identifier, and understand the comments. Then we have configuration language syntax, understand the blocks, arguments, identifier, and Terraform configuration and configuration syntax. This is the point I explained yesterday theoretically, that the template, the syntax of Terraform blocks are block type, block label. You can have multiple labels, and then identifier and the expression. This is the simple syntax of any Terraform block. Now the same block with respect to AWS, if I explain, if you look at block type is resource, block type, the block label is AWS instance, block label is EC2 demo. That means this is the instance that will be created. This is the block initialization. Then AMI, the image ID. Then instance type, where.instance type. That is interesting. This means that this will come from a variable with the name instance underscore type. So argument with value as expression, that is variable value replaced from the variables.tf file. So hence the instance type value will come from the file variables.tf. And point to be noted, you don't have to specify variables.tf anywhere. Terraform will process, I'm again highlighting, emphasizing, Terraform will process all the .tf file from your directory. So you don't have to explicitly mention it from where this variables.tf file will be called. From the same directory, it cannot go to any other directory apart from the current directory. Then understand about the arguments, attributes, and meta arguments. Here we have some arguments which are required and which are optional. Attributes format look like resource type, resource name, attribute name, and meta argument change the resource type behavior, for example count or for each. We'll have additional links for your reference, and understand about Terraform top level blocks. So let's go and directly open the Terraform manifest. So first was this Terraform blocks. Now this is the code which is given, and there's one file here, top level blocks sample.tf. This file is outside the Terraform manifest. If I see, yeah, this is the main file we have. Do we have variables? Let's verify. Not in this for sure. Let's go one by one. Block 1, Terraform settings block. This is comment. Interestingly, comments are replaced with comments are used, or comments are included with hash. Terraform required version. This time we are specifying which version of Terraform we'll be needing. And the required provider is AWS. This is what I explained in the previous part also. Backend is S3, means we'll be talking about the storage bucket as an example. This is just an example. Adding backend as S3 for remote state storage with state locking. And this is the bucket name I have on my Terraform, on my AWS account, and the key is stored into dev2.terraform.tf state. And then region is US East 1. This is the location, the backend where configuration will be stored. This is the S3 for remote storage with state locking. Then this is another use lock file. Yes, true. That means we'll be using the locking file. Then block number 2 is provider block. That was Terraform setting block. This one is the provider block. Same AWS default region. Then resource block, AWS instance, name of the instance, AMI ID, and the instance type is coming from where.instance type. Then variable instance type. Then default is T2 micro, and the description is EC2 instance type, and the type is string. This is the variable I was talking about. Look at the instance carefully. This is a variable. We use the term variable instance type, and this is the name which is coming from here, instance type. What is the default value? It is T2 micro, and the description and type is string. I explained theoretically the concept of variables. Now output value block. EC2 instance, you give any name, but you have to remember what name you have given, because you may have to refer to it in other blocks. Output is EC2 instance public IP, and the description is EC2 instance public IP address. Value is coming from AWS instance. This must be there somewhere, because it is getting the value from AWS instance. Do we have that? Yes. Yeah, it is there. AWS instance dot my EC2 VM. This has to be there somewhere. My EC2 VM, and this is going to be the name of the instance, and then from there it will capture the public IP, the value. Then local values block. The block name prefix is var.app name, var.environment name, and then this is a data block to print the value. Like here, data is AWS AMI, AMZ Linux. The most recent is true, honor is Amazon, filter name the AMI HVM. These are the different values and the different image available that can be used. Then another block is module block here, AWS instance module. Source is Terraform AWS module, EC2 instance AWS. The version of the module, module demo, and then AMI that will be used from the data, AWS AMI, Amazon Linux ID. Instance type is T2 micro, key is a Terraform key, monitoring is true, and the VPC security group ID. This is what I have used, and let me show you the security group from my ID. Let's go to the security group. Here, if I go to the VPC, I'll show you the security group also here, security groups. And this is the name of the security group that is used by this. If you look at the security group needs to exist, and this is the security group we are referring. If we go back, let me show you the security group ID is ending with 3E2E7, and that will be the same name. You can see, no, this is different one. Maybe I have another group, and the subnet ID which I have created, and the file name is apache to install.sh. This file apache install.sh has to be there. This may fail. Let me try and show you if it is failing or it is successful. Terraform true environment is development environment. Let's verify. I'll open the terminal, Terraform manifest, and here we have only one file, ls-al. Please note that if you have .terraform file, that means you have already run the command Terraform in it. So I'm cleaning this up so that I can show you from beginning. rm-rf .terraform and star top level blocks sample. Let me go and show you the S3 part also, which was referred. This is a S3 bucket I'm referring to, and in this S3 bucket, this was the bucket name that was referred. Let's go back and run the same command. Commands remain the same, Terraform init. This command will download the plugin and put that into .terraform directory. After that, we will run Terraform plan. Process is quite simple, plan. That is what I was talking about, that this is failing because this top level public IP, this is a reference to undeclared resource, and I was aware of that. This has not been declared my EC2 VM. So I'm skipping this part because this has not been declared, and there were a couple of issues and declaration related issues. Setting provider resources, and I'm opening this folder now. So inside this, what we will learn in the session quickly is Terraform setting, provider and resource block. Same. You can see the instance.terraform providers. I already explained this, but this time we are using additional blocks. Like we'll be using The credential part is already there, the provider name configured, the instance details, and the file name. We will be installing some packages. That is interesting. App1 install.sh, very interesting. This file will be executed on the instance, meaning that we are going to install Apache and we are going to configure this into where .html index.html, and the page should be open. Very interesting. That means we are not only launching an instance, but we are configuring it as a web server also with a default website. Interesting. So same set of commands. Let me show you the same thing. I'll open the terminal, new terminal. Now inside this, let's go to the Terraform. Now ls-l, these are the files I have. This is the script which I was talking about, cat -n app1 install.sh, and this script is taking care of the installation. If you notice, this script will be executed to configure web server on my instance. Let's look at the C1 file, cat -n C1 versions. This file is talking about the Terraform version. This time we are using a different approach, a little better approach, because we are dividing the code. We are not putting everything in a single file. We are dividing the code into multiple files. So if you notice, we are putting Terraform and provider in one file. That's the minimum code. Fantastic. That's a modularity is ensured. So we have first file, the script, second is C2 version, and third is C2 EC2 instance. Let's check this file also, cat -n C2 EC2 instance, and this is quite easy. Look at this file. Interestingly, resource is AWS instance, name of the instance for Terraform, AMI ID, then instance type, then subnet ID. This is same subnet which I've used, which I've created, and the user data. This is the magic. The magic is that after the instance is launched, this file from the current directory, that is app1 install.sh, will be executed on the instance, and the name of the instance is EC2 demo. Wow. So let's run the command terraform plan, init first, of course. Always remember terraform init, terraform plan, terraform validate, terraform output, terraform apply. These are 3-4 commands, nothing much. So terraform plan, and terraform validate, and terraform apply. And this will not only create an instance, interestingly, but also install a web server on the instance, and we will be able to see that web page. And so therefore the new learning in this session is how to execute a file on the newly created instance. Now we can see that now terraform output command. Let me show you what are the next command to be executed. And here you can see after that I just now executed this part, terraform plan, terraform apply. All right. And now we can check that resources in the cloud. Go back to the instances, EC2 instances running. Now it is status is checking, because I know that it takes some time for the instance to come up. And look at the name also coming properly now, EC2 demo. That was the name we gave. I'll visit the URL, the public IP address, and I should be greeted by that welcome page. Let's confirm that here. Access the index, that is index.html file, once the instance is ready. So I'm going to use the public IP address. Let's wait for a few more minutes. It is still working. I can use the public IP address and directly connect to the instance and check that what is going on. And this will connect to the instance. And let me check systemctl status HTTPD. And see, HTTPD is running. Page must be, yeah, it is available. Congratulations. Yes, we have a HTML page running and the website is reachable. So instance is ready, web server is configured, and website is reachable. Now we can simply run what? Terminate, because we just now verified it. And the metadata also, I can call that metadata. Let me show you the metadata part. Public IP address /app.html. And this will show you the metadata of the instance. You can see that account ID, architecture, availability zone, billing product, and the values, image, instance ID. You can see entire data about your instance. Here I just now demonstrated this part. Destroy, Terraform plan destroy, Terraform destroy. So this is the command. You can view the destroy plan using this command, but I'm going to run the command Terraform destroy straight away. So Terraform destroy. So this will destroy all the resources created by this Terraform. Yes. And now if I go back and check, it will take some time, but it will destroy finally. Eventually it will destroy these resources. Gone. All right, that's all for this session. Thank you very much for watching.